A Russian military convoy moves toward Ukrainian positions, but before the formation can create real pressure, the sky above has already seen every movement. From the ground, it may look like a normal convoy on the move. Military vehicles, ammunition trucks, self-propelled artillery, and support vehicles pushing toward the combat zone. But from above, the picture looks completely different. Each vehicle starts becoming a data point. Every turn, every stop, and every gap between vehicles can be tracked, measured, and turned into coordinates. And once the target has been watched long enough, the first strike can hit almost any weak point in the formation. The lead vehicle, an ammunition truck, a self-propelled gun, an air defense system, or even a command point deeper behind the line. So how did Ukraine turn a moving convoy into coordinates? Why does a HIMARS launcher become far more dangerous when it is connected to real-time data from above? And what is making traditional mechanized convoys increasingly difficult to keep alive in a battlefield covered by drones? Let's find out with military force. A Russian convoy becomes vulnerable long before the first rocket lands. The decisive moment begins when a Ukrainian reconnaissance UAV finds the column, follows its movement, and turns an ordinary road march into a trackable military pattern. From the ground, the vehicles may appear to be moving with order and purpose. Drivers watch the road, commanders measure distance, and support trucks try to keep pace with armor and artillery. From above, the same movement looks very different. The UAV can see the lead vehicle, the spacing between trucks, the points where the column slows down, and the places where it bends around trees, buildings, or open ground. That overhead view gives Ukraine more than a dramatic image. It gives a record of movement. A drone crew can observe whether the convoy is advancing, stopping, tightening, spreading out, or trying to hide. Each change helps build a clearer target picture, especially when the column includes ammunition trucks, self-propelled artillery, command vehicles, or fuel transport. This is why reconnaissance drones have become the first link in the Ukrainian strike system. They do not need to destroy the target by themselves. Their task is to find it, keep eyes on it, and help pass usable coordinates to the fire unit waiting behind the line. HIMARS becomes far more dangerous when this sensor link works quickly. The launcher does not need to sit close to the target or see the convoy with its own crew. It needs accurate location data, a clear target priority, and enough time to fire before the Russian vehicles move away. That connection changes the meaning of precision fire. HIMARS is not only a launcher in this situation, it becomes part of a wider chain that begins in the air, moves through data links, and ends with a rocket arriving at a selected point. The faster that chain works, the less time the convoy has to react. The pressure on Russian forces comes from this timing. A convoy can carry armor, troops, ammunition, fuel, and repair vehicles, but that strength becomes exposed if the formation is tracked from above. The larger the column, the more details it gives away. The slower it moves, the longer the drone can watch. This is the new danger on the Ukrainian battlefield. Survival is not decided only by armor thickness or engine speed. It is decided by whether a unit can move before it is detected, hide before coordinates are passed, and leave before precision fire arrives. From the moment those coordinates move through the Ukrainian network, the Russian convoy is no longer just a force on the road. It becomes a target waiting for the next stage of the attack, close behind. A Russian convoy is most exposed when it is between positions, because movement creates order on paper, but confusion on the road. Vehicles do not all move at the same speed. Heavy armor slows on rough ground, trucks need space to turn, and artillery crews must avoid soft soil, damaged bridges, and roads watched by drones. When one vehicle slows, the rest of the column reacts, and a long formation can lose shape within minutes. This is the moment HIMARS is built to punish. Ukraine does not need to wait until the convoy reaches the trench line. If the target is identified while moving toward a firing position or a supply point, the strike can hit before the force becomes useful. A unit that was meant to support an assault can suddenly block roads, delay nearby troops, and force commanders to change the timetable under pressure. Ammunition trucks are especially valuable targets because they carry the future firepower of the front. They may not look as dramatic as a tank, but their cargo feeds guns, rocket launchers, mortar teams, and infantry units already under pressure. When an ammunition vehicle is lost, the damage is counted not only in metal and tires. It is also counted in shells that will not reach a battery, rockets that will not be loaded, and resupply trips rebuilt under danger. Fuel and repair vehicles create another layer of weakness. A convoy can include combat vehicles that seem strong, but those machines depend on diesel, spare parts, recovery trucks, and mechanics. If these support elements are hit, armor may still exist on the map, but its ability to move, withdraw, or return to action becomes weaker. In a fast battle, that delay can matter as much as direct destruction. Self-propelled artillery and MLRS are also vulnerable at the moment they prepare to fire. These systems are designed to move, shoot, and leave, but the process still requires a pause. Crews need to select a firing point, align the launcher or gun, prepare ammunition, and complete the mission before enemy fire arrives. That short pause creates danger. If a reconnaissance drone has already followed the vehicle, HIMARS can strike when mobility is lowest and exposure is highest. The value of such a strike is not limited to the destroyed platform. A self-propelled gun is part of a wider fire plan. It supports infantry, pressures Ukrainian positions, and helps Russian units advance or hold ground. If it is hit before or after firing, the effect spreads beyond one vehicle. Nearby Russian units may lose planned fire support, and the next movement can begin with less cover than expected. Convoys near the front also suffer from geography. Roads, tree lines, villages, and damaged fields leave only a few usable routes. Drivers may try to hide beside trees or stop near buildings, but those same places can restrict escape. A precision strike in such a setting does more than damage a vehicle. It can freeze traffic, force troops to abandon equipment, and create a point of disorder that other units must avoid. This is why timing matters as much as accuracy. HIMARS is not only useful because it can hit a target from a distance. It is useful because it can hit when that target is least ready to absorb the blow. A convoy on the move, an ammunition truck near the front, or an artillery system paused before firing all share the same weakness. They are valuable, exposed, and operating inside a narrow window. One destroyed vehicle may look like a small event, but a strike on the right vehicle at the right moment can slow reinforcement, interrupt resupply, and reduce Russian firepower before it reaches the fight. But in many HIMARS strikes, the damage does not end with the first explosion, because the most dangerous part of the target is often hidden inside. Secondary explosions matter because they reveal what the first impact has reached. A blast may destroy a vehicle, but the fire that follows can show a deeper loss. If ammunition cooks off or fuel burns across the site, the target was not just metal on a road. It was part of the supply system that keeps Russian guns firing and vehicles moving. This is why an ammunition truck is more valuable than its shape suggests. From a distance, it may look like transport, but inside it can carry shells and rockets for artillery batteries, BM-21 launchers, mortar teams, and assault units near the front. When HIMARS hits such a truck, the loss spreads into the next hours of fighting. A battery may wait longer for rounds, a unit may reduce fire, and a planned attack may begin with less support. The same logic applies to self-propelled artillery and rocket launchers. These platforms are dangerous because they combine movement with firepower, but that strength depends on ammunition stored close to the crew and weapon system. When a strike reaches that storage, the result can be larger than the first explosion. A burning gun, a destroyed launcher, and detonating rounds can remove a firing asset from the fight. Russia then loses the vehicle, crew, prepared ammunition, and the support that weapon was expected to provide. Fuel creates another layer of damage. A fuel vehicle does not have to be on the front line to shape the front line. Tanks, armored carriers, recovery vehicles, trucks, and generators all depend on it. If a fuel point burns, movement across the area can slow. Vehicles may still exist, but they cannot operate at the same pace. Commanders may have to delay movement, change routes, or send new supplies into an area watched by Ukrainian drones. Logistics hubs are sensitive because several needs often meet in one place. Ammunition, fuel, spare parts, repair teams, and transport vehicles can sit close together for speed and control. That concentration saves time in normal conditions, but it creates risk when precision fire is guided by reconnaissance drones. One accurate strike can start fires, trigger ammunition, damage nearby trucks, and force personnel to abandon the site before supplies are moved. The wider effect is often larger than the video suggests. Viewers may remember the fireball, but the real damage is measured in lost tempo. A frontline unit that expected shells, fuel, or repair support may receive less than planned. A gun line may fire fewer rounds. A convoy may need a new route. A commander may pause an assault until the supply gap is repaired. The strike may be local, but the shortage can travel across nearby positions. This is the deeper value of HIMARS in this role. It does not only break equipment, it attacks the rhythm that keeps Russian combat power functioning. Modern armies do not fight with tanks and guns alone. They fight through supply cycles, repair cycles, fuel movement, ammunition delivery, and planned windows of fire support. When those cycles are disrupted, the battlefield effect can appear far from the strike location. Secondary explosions turn a precise strike into a larger warning. They show that Ukraine is not only hitting what can be seen on the road, it is striking the stored energy behind Russian operations. After convoys, artillery, and supply nodes are hit, the next target becomes more important. The air defense systems protecting Russia's rear battlefield from Ukrainian follow-on strikes. Russian air defense becomes a priority target because it protects the system behind the front. A Buk launcher is not just another expensive vehicle. It is part of a shield around convoys, ammunition points, artillery positions, command sites, and rear areas close enough to support the battle. When Ukraine strikes that shield, it is not only removing one machine from the field. It is weakening the cover that allows other Russian assets to move, hide, and prepare. The Buk system matters because it sits in the middle layer of air defense. Short-range systems may guard local positions, while heavier systems watch wider areas. But Buk helps protect the space between them. That space is where reconnaissance drones often search for movement, where strike drones look for openings, and where precision fire needs confirmation. If one Buk battery is damaged or forced to move, the protected zone around it can shrink. Russian commanders may then have to choose between exposing logistics, moving another air defense asset forward, or accepting more risk from Ukrainian surveillance. Ukraine does not only target vehicles that explode easily. Ammunition trucks, fuel points, and artillery can create visible destruction, but air defense shapes what can be seen and struck later. A Buk system may not produce the same kind of fireball as a fuel vehicle, yet its loss can change the conditions for the next attack. It can give Ukrainian UAV crews more room to observe roads, tree lines, and staging areas. It can also make Russian support units less confident when they move near the front. A damaged air defense network creates pressure beyond the strike location. Russia cannot protect every road, supply point, and command site with equal strength. If Buk units must relocate, spread out, or stay hidden to survive, they may cover less ground. If they activate radar, they may reveal themselves. If they stay silent, they may protect less effectively. Every choice creates a weakness somewhere else in the network. This becomes especially dangerous in a battlefield where reconnaissance drones can search large areas and pass information quickly to fire units behind the line. For Ukraine, attacking Buk is a way to prepare the battlefield before the next strike. Once the protective layer is reduced, reconnaissance becomes easier, and target confirmation can happen with less risk. Command posts, logistics hubs, troop concentrations, and artillery positions then become more exposed to follow-on attacks. The first strike against air defense may therefore serve a larger purpose. It opens space for later operations. The political and military meaning is clear. Modern war is no longer only about destroying a visible target. It is about weakening the system that keeps those targets protected. A convoy can be replaced, and a gun can be moved, but a damaged air defense layer changes how nearby units operate. Movement becomes more cautious. Supply routes become more difficult. Commanders may delay activity because the sky above them feels less secure. After convoys, artillery, and supply nodes are hit, Ukraine's focus on book shows a broader method. It is not just hunting equipment. It is reducing Russia's ability to protect the rear battlefield. When reconnaissance drones, precision rockets, and battle damage assessment connect into one process, a larger pattern begins to appear. Ukraine is building a faster kill chain, where every destroyed shield can make the next target easier to reach. Speed is the heart of Ukraine's strike chain, because a moving target survives only if it escapes before the fire mission is complete. The process is simple in structure, but difficult in execution. A UAV finds the convoy, watches its direction, and identifies the most valuable part of the formation. Coordinates then move to the fire unit. HIMARS launches. The drone remains overhead to confirm the result and look for another opening. This cycle matters because time protects a convoy. If Russian vehicles can turn off the road, spread into tree lines, or break into smaller groups, the target picture becomes harder to use. If they remain in view for a short window, the danger grows quickly. The strength of the Ukrainian system is that it compresses the gap between observation and impact. A convoy that looked mobile earlier can suddenly be caught inside a planned strike. The most dangerous method is to attack the structure of the column, not only one vehicle. A convoy depends on flow. The lead vehicle sets direction. The rear vehicles preserve movement and help keep the route open. The middle section carries much of the weight, including troops, ammunition, support trucks, or artillery assets. If the front is hit, the column loses momentum. If the rear is hit, the escape route tightens. If the middle is struck next, the formation can break into confusion. This is why narrow roads, wooded lanes, village edges, and damaged approaches are dangerous. They give vehicles fewer ways to move away from the impact area. A driver may want to leave the road, but mud, mines, trees, or ruined ground can block that choice. A commander may order vehicles to disperse, but space may not allow it. The convoy then loses the main advantage it had before the strike, which is mobility. Once that happens, HIMARS is no longer only destroying equipment. It is changing the behavior of the whole formation. Vehicles stop where they should keep moving. Crews hesitate when they should accelerate. Support trucks may block armored vehicles, and damaged equipment can turn a road into an obstacle. The strike creates disorder, and disorder gives Ukrainian observers more time to watch what remains. The follow-up stage is as important as the first impact. A UAV that stays above the area can confirm which vehicles are burning, which ones are trying to escape, and which part of the column is still usable. That information can guide another strike, or it can help other Ukrainian fires finish exposed targets. In this way, the kill chain becomes a living process rather than a single launch. From this point, the battlefield logic widens. If Ukraine can lock a convoy by striking its weak points, the same model can be used against larger systems. The next targets are no longer only vehicles on the road. They are command posts, artillery sites, troop concentrations, and logistics hubs that keep Russian operations moving. HIMARS now reaches beyond convoy hunting and strikes the organs that keep Russian operations moving. A command post is valuable because it connects orders, artillery requests, supply routes, reinforcements, and battlefield reports. When that node is damaged, the effect is not limited to one building or one group of officers. Units may wait longer for instructions, artillery may receive slower corrections, and nearby forces may lose the clear direction needed during a fast assault. Troop concentrations create another target set. Before an attack begins, soldiers often gather near roads, tree lines, abandoned structures, or staging areas where vehicles can move them forward. If HIMARS hits that gathering point, Ukraine can reduce the pressure before it reaches the trench line. The assault may still be ordered, but it begins with fewer men, damaged vehicles, and weaker timing. Artillery positions are just as important because Russian ground attacks often depend on heavy fire before movement. Guns and rocket launchers prepare the way, suppress Ukrainian defenders, and try to make infantry advances less costly. When these positions are hit, the loss affects more than the weapon itself. The local front may receive less cover, assault groups may move under greater risk, and commanders may delay pressure until new fire support is arranged. Logistics hubs complete the picture. Ammunition, fuel, spare parts, trucks, recovery vehicles, and repair teams form the quiet structure behind every visible attack. If a hub is struck, the damage travels outward through the force. Vehicles may wait for fuel, guns may wait for rounds. Damaged armor may stay out of action longer. The front line may still look active, but its tempo begins to weaken from behind. This wider use of HIMARS shows how modern war is becoming a contest between sensors, data, and precision fire. The launcher is only one part of the system. Reconnaissance drones find the target, data links move the information, fire units strike, and observers confirm the result. When this chain works, Ukraine does not need to destroy every Russian asset directly. It can hit the points that help those assets move, shoot, gather, and receive orders. That pressure changes planning before another movement starts. That is why the question now reaches beyond one convoy or one strike. If major movements can be watched, mapped, and targeted, can traditional mechanized formations survive in a battlefield covered by drones long after the first impact has faded? This is not only a story about destroyed Russian convoys. It shows how modern warfare is moving toward a harsher rule. A target can begin to lose the moment it is seen. Ukraine has made reconnaissance UAVs and HIMARS part of the same battlefield system, where observation, data, and precision fire work together. Russia still has armor, artillery, air defense, and logistics, but those assets become harder to use when movement is watched from above. To adapt, Russian forces may spread convoys, improve camouflage, rely more on electronic warfare, move at night, and divide supply points into smaller sites. Yet every solution brings a cost. Smaller convoys slow delivery. Hidden depots complicate supply. Night movement does not remove drone risk. HIMARS is no longer just a rocket launcher. Connected to drone ISR, it becomes part of a system that turns movement into coordinates. For more clear analysis on modern warfare, battlefield technology, and the geopolitical decisions shaping today's conflicts, make sure to subscribe to Military Force. The purpose of this content is not to glorify war, but to help viewers better understand the military and human realities behind modern conflicts. Because the more clearly people understand war, the more clearly they can understand the importance of stability, diplomacy, and peace.